Well, good afternoon or good morning, class. We're going to talk about the topic today is going to be making economic decisions. Uh, Making economic decisions. What I would like to focus today is that you understand that is when you are facing different issues or problems, you will need to go through a criteria process in which you will be able to select the best alternative. All this criteria process is called making economic decisions. Another important aspect to indicate is that decision making is a broad topic. For it is a major aspect of everyday human existence. Correct? We all make decisions almost every day. You wake up, what time you wake up, what time do you sleep, what what ice cream are you going to eat today, what will be your lunch, what will be your breakfast, what you are going to answer when someone asks you a question. So in this chapter or in this lecture, we're going to develop tools to properly analyze and solve the economic problems that are commonly faced by engineers. Even very complex situations can be broken down into components from which sensible solutions are produced. If one understands the decision-making process and have tools for obtaining realistic comparisons between alternatives, one can expect to make better decisions. Also, we will focus on solving problems that confront firms in the marketplace. We will also use examples of how these techniques may be applied to the problems faced in daily life. Since decision-making or problem-solving is our objective, let us start by looking at some problems. People are surrounded by problems. I don't want to make this lecture negative, but it's the truth. Sometimes we all face problems. For instance, could happen that we are in our career. What we like to, for instance, right now we are engineers, correct? But what happened if one day, for instance, if one day we decided that we want to be economists? After, for instance, we take this class, we say, oh, I like this class, I like economics. So you decided, okay, you know what, I want to be economist. What will be your solution for that problem? Well, remember that sometimes there are graduate studies and you can do a master in economics. So you have your background engineer, and with your master in economics will give you a good combination and will allow you to work as economist as well. So that could be a solution. Another problem could be, for instance, before you come to class, sometimes you can wake up late and you will have to come to class. So you decided maybe to take the metro, but rather than take a taxi, that you could save some time. Correct? So at the end is a decision. You have a problem that you wake up late, so you need to take a decision if how you're going to be able to what decision you should take to be able to come to class early. No? Another important aspect is that the problems are often not isolated from each other, because one solution that you decided to go through, or the one solution that you that you choose, could bring you another problem as well. Correct? So problems are not related of each other. Organizations have opportunities. Correct. Organizations have opportunities. Every time, and this is more getting into the job aspect. For instance, if we are working in a firm, all of us are head of our project managers, and we are doing a road that need to be delivered in 2 days. And in the road start to appear cracks or start to appear potholes just 1 day before the delivery day. And the delivery day is the opening day when the mayor is going to come to open the road. So this is a big problem. What solution you will take? Maybe you can hire labor, you can bring more people, and you leave the people that you're working now to continue moving with the other tasks to be able to deliver in the expected day. Or with the new people, you can bring new people and start to fix the problem, start to fix the different potholes or cracks that are on the road. Another solution could be use an innovative liquid to be able to fill in the potholes on cracks and fix the road. So there are different opportunities. Every problem brings with you different opportunities. The seniors concerning these opportunities may be arrived at with the help of economic analysis. So economic analysis will help you to come out with these opportunities and be able to get out of the problems. Now, a careful look at the world around us clearly demonstrates that we are surrounded by a set of problems. There does not seem to be any exact way of classifying them, simply because they are so diverse in complexity and personality. One approach would be to arrange problems by their difficulty. Consequently, we are going to divide it in three different problems: simple problems, intermediate problems, and complex problems. Simple problems, on the lower end of our classification of problems, are simply situations, are simple situations. For example, should I pay cash or use my credit card? Do I buy a semester parking pass or use the parking meters? Shall we replace the burned out motor? If we use 3 crates, CRATS, TES, of an item a week, how many crates should we buy at the time? Or for instance, if you didn't bring a lot of money today, you forgot your money, you will start to think, do I going to drink a coffee or I going to have lunch? Because if you have less money, maybe you can drink a coffee, but you will have a light lunch, or you can escape coffee and have a good lunch because again, you didn't bring the normal funds that you used to bring to be able to eat during the day. Let's start a little more in detail about intermediate problems. The good thing with simple problems is that I'm talking about simple problems, is that these are pretty simple problems and good solutions do not require much time or effort. So it's very easy to come out with a solution. Maybe you don't need neither to go through this decision-making process for a simpler problem. But in the case of intermediate problems, at the middle level of complexity, we found, and these problems that I'm talking about, the intermediate problems, are at the middle level of complexity, and most of the time are related with economic aspects. For instance, shall I buy or lease my next car? Which equipment should be selected for a new assembly line? Which materials should be used as roofing, siding, and structural support for a new building? Shall I buy 1 or 2 semester parking pass? No? And the complex problems, at the upper end of our classification system, we discover problems that are indeed complex. They represent a mixture of economics, political, and humanistic elements. Remember, they represent a mixture of economic, political, and humanistic elements. Now, let's start a little more. I'll go a little deeper for of them, intermediate and complex, because as I said before, the simple problems are good solutions do not require much time or effort. In the specific case of the intermediate problems, please keep in mind that are sufficiently important to justify serious actions, and also are primarily economic or have a significant economic aspects. Another important aspect is that are generally adequately solved with single criteria decision making. So solving this, you don't need to have too much steps that you need to evaluate. A single criteria decision making is applied and you will come with a solution faster. In the case of the complex problems, again, which represent a mixture of the three elements, economic, political, and humanistics, are a little more complex to solve. For the specific of this course, we are not going to much in detail how to solve complex problems. However, it's important to mention that solving complex problems need a multidisciplinary team with different aspects. Let me give you a specific example of a complex problem. The decision of Mercedes-Benz to build an automobile assembly plant in Minneapolis, Alabama, or Minnesota illustrates a complex problem for them. Besides the economic aspects, Mercedes-Benz has to consider possible reactions in the American auto industry. Will the German government pass legislation to prevent the overseas plant? What about German labor unions? Another problem could be also the selection of a girlfriend or boyfriend who may later become a spouse. It's obvious a complex decision. Economic analysis can be a little or no help with this specific matter. At the end, you have to have all the criteria to be able to select who will be your partner of your life. Another important topic that we're going to discuss is the role of engineer economic analysis. Engineering economic analysis is most suitable for intermediate problems and economic aspects of complex problems. They have these qualities. The problem is important enough to justify our giving it serious thought and effort. The problem can be worked in one's head. That is, a careful analysis required that we organize the problem and all the various consequences, and this is just too much to be done all at once. One second, because so I'm just going to plug in. Okay. So when problems, and I say the last one, which is I say about the three qualities. The last quality, just in case to repeat it, is the problem has economic aspect important in reaching a decisions. When problems meet these three criteria, which is the problem is important enough to justify a serious action, the problem can be worked in one head, so not only one person can solve it, and the problem have economic aspects. That is when you start to focus in engineering economic analysis. Since vast number of problems that one will encounter in the business world meet this criteria, engineering economic analysis is often required. Engineering economic analysis focuses on costs, revenues, and benefits that occur at different times. For example, when a civil engineer designs a road, a dam, or a building, the construction costs occur in the near future. The benefits to users begin only when construction is finished, but then the benefits continue for a long time. In fact, nearly everything that engineers design calls for spending money in the design and building stage. And after completion, revenues or benefits occur usually for years. Thus, the economic analysis of cost, benefits, and revenues occurring over time is called engineering economic analysis. Engineering economic analysis is used to answer many different questions. Which engineered problems are worthwhile? Has the mining or petroleum engineer showed that the material or oil deposit is worth developing? Which engineered project should have a higher priority? Has the industrial engineer shown which factory improvement projects should be funded with available dollars? How should the engineered project be designed? Has the mechanical or electrical engineer chosen the most economical motor size? Has the civil or mechanical engineer chosen the best thickness for insulation? Has the aeronautical engineer made the best trade-off between lighter materials that are expensive to buy but cheaper to fly, and heavier materials that are cheap to buy and more expensive to fly? Engineering economic analysis can also be used to answer questions that are personally important. How to achieve long-term financial goals? How much should you save each month to buy a house, retire, or a fun trip around the world? Is going to graduate school a good investment? Will your additional earning in later years balance your lost income while in graduate school? How to compare different ways to finance purchases. It is better to finance your car purchase by using the dealer's low interest rate loan or by taking the rebate and borrowing money from your bank or credit union. How to make sure a long-term investment decisions. It is higher salary better than stock options. Should you buy 1 or 2 semester parking pass? All these questions are part of the role of engineering economic analysis. Now, let's start to talk about the decision-making process. The decision-making may take place by default. That is, a person may not be consciously recognize that an opportunity for decision-making exists. This fact leads us to a first element in a definition of decision-making. To have a decision-making situation, there must be at least 2 alternatives available. If only one course of action is available, there can be no decision-making. For there is nothing to decide. There is no alternative but to proceed with the single available course of action. More frequently, alternatives simply are not recognized. At this point, we may conclude that the decision-making process consists of choosing from among alternative courses of action, but this is an inadequate definition. Consider the following. At a racetrack, a bettor was uncertain about which of the 5 horses to bet on in the next race. He closed his eye and pointed his finger at the list of horses printed in the racing program. Upon opening his eyes, he saw that he was pointing to the horse number 4. He hurried off to the place his bet on that horse. Does the right horse selection represent the process of decision making? Yes, it clearly was a process of choosing among alternatives. But the particular method of deciding seems inadequate and irrational. We want to deal with rational decision making. Rational decision making is a complex process that contains 9 essential elements, which are shown in this slide. Although these 9 steps are shown sequentially, it is common for decision making to repeat steps, take them out of order, and do steps simultaneously. For example, when a new alternative is identified, then more data will be required. Or when the outcomes are summarized, it may become clear that the problem needs to be redefined or new goals established. The value of these sequential diagrams is to show all the steps that are usually required and to show them in a logical order. Occasionally, we'll skip a step entirely. For example, a new alternative may be so clearly superior that it is immediately adopted as step 4 without further analysis. The 9 steps for the decision-making process are: first, recognize a problem. Second, define the goal or objectives. Third, assemble relevant data. Fourth, identify feasible alternative. Fifth, select criterion to determine the best alternative. 6. Construct a model. 7. Predict each alternative outcomes or consequences. And 8. Choose the best alternative. And finally, audit the result. Through this presentation, we're going to start to talk and start to describe each of these different decision-making process steps. The first one is recognize the problem. When we are talking about recognize the problem, is the starting point in the rational decision making. Is recognizing that the problem exists. This is very important because if you do not recognize that there is a problem, could be very difficult for you to set up the solutions. Consequently, it's very important to know that the existence of this problem. Let me give you an example. Some years ago, it was discovered that several species of ocean fish contained substantial concentration of mercury. The decision-making process began with this recognition of a problem, and the rush was on to determine what should be done. Researchers revealed that these fish taken from the ocean decades before and preserved in laboratories also contained similar concentrations of mercury. Thus, the problem had existed for a long time but have not been recognized. There was always problems of mercury in the fish and exist for a long time, but before it was not recognized. Now, the reason could be that many years ago you didn't have the equipment to be able to identify the mercury. So it could be X reasons. However, the problem was not recognized or identified many years ago. In typical situations, recognition is obvious and immediate. An auto accident, an overdrawn check, a burned out motor, and a exhaust supply of parts all produce the recognition of a problem pretty quick, correct? Once we are aware of the problem, we can solve it as best we can. Many firms establish programs for total quality management or continuous improvement that are designed to identify problems so that they can be solved. So there are teams within the firms that are constantly identifying problems, looking what are the things that are happening, and bringing new ideas to be able to solve this problem within the companies. Remember something, a problem is defined when a standard or expectation is not being met, or when a new standard or expectation appears. Could be the possibility that you are doing a project and your client asks you additional work for that project. So you have a new expectation, and your problem is to try how you're going to meet this new expectation. Correct? So just also keep that in mind. The second point, which we are going to talk, is define goal and objectives. Define a goal and objectives. How we're going to define a goal or objectives? The goal objectives can be a grand overall goal of a person or a firm. Let me give you a specific example. A personal goal could be to lead a pleasant and meaningful life, and a firm's goal is usually to operate profitable. The presence of multiple conflicting goals is often the foundation of complex problems. Correct? Because if you're having two different goals that are conflicting each other, is when you are really going to have complex problems. There are, for instance, multilateral organizations where sometimes they create departments where they compete each other. So you are an organization, a multilateral organization, and inside you're creating departments that they are doing the same thing. So at the end, you are conflicting your institution and you're creating problems. Correct? But an objective needs to be a grand overall good of a business or an individual. It may be quite narrow and specific. Let me give you an example. I want to pay off the loan of my car by May. Or the plant must produce 300 golf carts in the next 2 weeks. Or I need to make sure that the city hall is happy with the work that we are doing for the road. Because if you keep your clients happy, you will ensure that they will continue hiring you and you will continue having more projects, correct? Now, let's go to the third point, which is assemble relevant data. What is assemble relevant data or information? Sorry, I'm just doing this to make sure that we are recording all these presentations. So that's the reason why you see me going there, just making sure that we are recording. Okay, let's continue. Assemble relevant data. To make a good decision, one must first assemble good information. That's correct? I cannot take a good decision if I don't have a good information. In addition to all published information, there is a vast quantity of information that is not written down anywhere, but is stored as individual knowledge and experience. There could be the possibility that you are doing a project of a dam in a specific place and the information is not anywhere. However, there was a person who used to work for that project, and maybe he have all the information in his computer at home when he used to work at that project. So your work will be try to find this person and try to get the information, correct? Another important aspect is that you can find a massive amount of data, but the problem or the situation is how you are going to make sure, how do you manage to identify what is the relevant data. This is a complex process, correct? Now, the other important aspect is in engineering decisions, in engineering decision making, the two important sources of data are the organization accounting and purchasing departments. Why they are the sources of data? Because they gather all the financial information that is needed to move ahead with the project. For instance, if you are working as a project manager and you are doing a road and you need some equipment, you need to go to the purchasing department. They already know what is your limit to buy equipment. So what is the limit and the funds available in your component of your project to buy equipment. Also, could be the possibility that they will suggest you not to buy the equipment. They have better information that maybe will tell you it's cheaper for you to rent equipment. Or another important aspect, could be the possibility that the equipment that you are looking, they already have tracked it. They already have the tracking of all this equipment, and this in another location. So you just need to bring it from one location to another location. That could happen. The most important aspect of this accounting and departments, purchasing departments, is that they have all this information gathered that allow you to help you to guidance how to move forward. The same situation, if you want to hire someone, you need to go with the accounting department. So they will tell you how much money available you have to be able to hire a new engineer or another person who can help you in the labs, correct? Now, the fourth point is identify feasible alternative. One must keep in mind that unless the best alternative is considered, the result will always be suboptimal. Two types of alternatives are sometimes ignored. First, in many situations, a do-nothing alternative is feasible. This may be the let's keep doing what we are now doing, or let's not spend any money on that problem alternative. And the second, there are often feasible alternatives such as patching it up and keep it running for another year before replacing it. There is no way to ensure that the best alternative is among the alternatives being considered. One should try to be certain that all conventional alternatives have been listed and then make a serious effort to suggest innovative solutions. Sometimes a group of people considering alternatives in an alternative atmosphere and brainstorming can be helpful. Even impractical alternatives may lead to better possibilities. The payoff from a new innovative alternative can far exceed the value of carefully selecting between the existing alternatives. Any good list of alternatives will produce both practical and impractical alternatives. It will be a little use, however, to seriously consider an alternative that cannot be adopted. Consequently, it's very important to make sure that only feasible alternatives should be retained for further analysis. Why? Because if someone brings you 10 alternatives and you consider all of them, you will lose your time doing a making process of alternatives that really is not taking you anywhere. So, those all the alternatives possible, just select those that are feasible before entering into the making process criteria. Now, select the criterion to determine the best alternative. The central task of decision making is choosing from among alternatives. How is the choice made? Logically, to choose the best alternative, we must define what we mean by best. There must be a criterion or a set of criteria to use which alternative is best. Now, we recognize that best is alternative, relative, adjective, or on one end of the following relative subjective judgments. What are these relative subjective judgments? Are worse, bad, fair, good, better, and best. Since we are dealing in relative terms rather than absolute values, the selection will be the alternative that is related the most desirable. Consider a driver found guilty of speeding and given the alternative of a $170 fine or 3 days in jail. In absolute terms, neither alternative is good, but on a relative basis, one simply makes the best of a bad situation. Correct? What would be best? To pay the $175 or to go 3 days of jail? I leave it up to you. But for me, in this bad situation, the best could be pay the $175. Correct? There may be unlimited numbers of ways that one might judge the various alternatives. Several possible criteria are create the least disturbance of the environment, improve the distribution of wealth among people, minimize the expenditure of money, ensure that the benefits to those who gain from the decision are greater than greater than the losses of those who are harmed by the decision, minimize the time to accomplish the goal or objectives, maximize your profit, minimize your unemployment. Selecting the criterion for choosing the best alternative will not be easy if different groups support different criteria and desire different alternatives. Let me give you a specific example with this. In the case of the road that there are potholes and cracks and you need to deliver in 2 days, could be the possibility that in your team there are a transportation engineer and there are chemical engineers. The transportation engineer maybe will bring you the alternative like, you know what, I think that it's much better if we hire new people, labor, and we try to make sure that this one is done apart from them. So another person who is the chemical engineer could suggest you to use this innovative liquid that will allow you to fill the holes, the cracks, and fix this pothole quickly. Consequently, you will have two different sets of criteria based on the background of the team of your members. Now, be careful because this also could bring conflicts. The disagreement between management and labor in collective bargaining reflects a disagreement over the objectives and the criterion for selecting the best alternative. The last criterion, maximize profits, is that one normally selected in engineering decision making. Again, the last criterion, maximize profit, is the one normally selected in engineering decision making. When this criterion is used, all problems fall into one of the three categories: fixed input, fixed output, or neither input nor output fixed. Fixed input, the amount of money or other input resources are fixed. The objective is to effectively utilize them. For example, a project engineer has a budget of $350,000 to overhaul a portion of a petroleum refinery. You save $300 to buy clothes for the start of school. For economic efficiency, the appropriate criterion is to maximize the benefits or other outputs. Fixed output. There is a fixed task, or other output objectives or results to be accomplished. Example, a civil engineer has been given the job of surveying a tract of land and preparing a record survey map. You wish to purchase a new car with no optional equipment. The economically efficient criterion for a situation of fixed output is to maximize the cost of the other inputs. Neither input or no output fixed. The third category is the general solution in which the amount of money or other inputs is not fixed, nor the amount of benefit or other outputs. Example, automobile batteries needed. Batteries are available at different prices and also to provide the energy to start the vehicle. The life of the battery are different. What should the criteria? What should be the criteria in this category? Obviously, to be as economical efficiency as possible, we must maximize the difference between the return from investment, the benefit, and the cost of investment. If the difference between the benefit and the cost is in profit, a business person will define this criterion as maximizing profit. For the three categories, the proper economic criteria are fixed input, maximize the benefit or other outputs, fixed output, minimize the cost of other inputs, neither input nor output fixed, maximize or state another way, maximize profit. Those are different situations with when we are talking about select the criterion to determine the best alternative. Now, construct a model. We're talking about constructing a model. We're talking about constructing a model. We have to make sure that we understand what is a model. A model is when you automatize, I repeat, when you automatize a mathematical process, correct? You are automatizing a mathematical process. For example, if you know that 30% is your midterm, 30% is your final, and 40% and your homework, you can prepare a spreadsheet and start to run different scenarios. What will be your grade? For instance, if you have in your homework a B, but then you have in your midterm a C, it's possible that you need to get for a final over B to be able to pass the class. So you're automatizing a process that allows you to run different scenarios to be able to know what will be your next step, and what will be your target in the different exams that you're going to take. So, constructing the model, at some point in the decision-making process, there are various elements must be brought together. So during the process of constructing a model, there are various elements that need to be brought together. The objectives, relevant data, feasible alternative, and selection criterion must be merged. Everything that we have been talking about has to be merged. So this is the way where you merge them through a model. Let me give you a specific example. If one were considering borrowing money to pay for an automobile, there is a mathematical relationship between the following variables for the loan: amount, interest rate, duration, and monthly payment. So you can build a Excel sheet where you start to do your calculations and you start to know what you're going to pay per month based on this calculation. Constructing the interrelationship between the decision-making elements is frequently called model building or constructing the model. To engineer, modeling may be a scaled physical representation of the real thing or a system or a mathematical equation or a set of equations describing the desired interrelationship. In a laboratory, there may be a physical model, but in economic decision-making, the model is usually mathematical. I will repeat this part because it's very important. In the laboratory, there may be a physical model, but in the economic decision-making, we are talking the model is usually mathematical. We're not talking about physical models. We're talking about mathematical. That's the reason why I emphasize the situation with the spreadsheets. In modeling, it is helpful to represent only that part of the real system that is important to the problem at hand. Thus, the mathematical model of the student capacity of a classroom may be capacity is equal to length of the classroom over classroom arrangement factor. In this equation, the student capacity of a classroom is a very simple model, correct? Yet it may be adequate for the problem we'll solve. Another situation could be, for instance, when you are calculating flows. Flow is equal to area times velocity. So this is a simple mathematical relationship in which you are relating area and velocity to be able to calculate flows in the river. correct? So keep that in mind when you are doing this. It's mainly, construct a model is mainly to bring all the elements that we have been talking before, bring it together. Okay, the objectives, relevant data, feasible alternative, and selection criterion must be merged in this stage, in this step. Now, predicting the outcome for each alternative. A model and the data are used to predict the outcomes for each feasible alternative. As was suggested earlier, each alternative might produce a variety of outcomes. Selecting a motorcycle rather than a bicycle, for example, make the full supplier happy, the neighbors unhappy, the environment more polluted, and one saving account smaller. But to avoid unnecessary complications, we assume that the decision making is based on a single criterion for measuring the relative attractiveness of the various alternatives. If necessary, one could be devise a single composite criterion that is the weighting average of several differential choice criteria. To choose the best alternative, the outcome for each alternative must be stated in a comparable way. Usually, the consequences of each alternative are stated in terms of money, that is, in the form of costs and benefits. This resolution of consequences is done with all the monetary and non-monetary consequences. Correct? The consequences can also be categorized as market consequence, extra market consequence, and intangible consequence. The first one, market consequence, is when there are established market prices available. Extra market consequence is when no direct market prices, so price indirectly. An intangible consequence is value by adjustment in non-monetary prices. So, in this stage, what we are trying to do is to avoid complications. We assume that a decision is based on a single criterion. Sometimes, multiple criteria are combined into a single criterion. Another important aspect is the consequence or alternative are stated in the form of money. We're talking everything related with money. And we bring the relation cost-benefit. We're going to talk more in detail about cost-benefit analysis, but in this case, we bring the relation cost-benefit. Now, A1 is choosing the best alternative. Earlier, we indicated that choosing the best alternative may be simply a matter of determining which alternative best meets the selection criteria. But the solutions to most problems in economics have market consequences, extra market consequences, and intangible consequences. Since the intangible consequences of possible alternatives are left out of the numerical calculation, this should be introduced into the decision-making process at this point. The alternative is to be chosen is the one that best meets the choice criterion after considering both the numerical consequences and the consequences not included in the monetary analysis. During the decision-making process, certain feasible alternatives are eliminated because they are dominated by other, better alternatives. Let me give you a specific example. Shopping for a computer online may allow you to buy a custom configured computer for less money than a stock computer in a local store. Buying at a local store is feasible but dominated, while eliminating dominated alternatives makes the decision-making process more efficient. There are dangers. Having examined the structure of the decision-making process, it is appropriate to ask, when is a decision made and who makes it? If one person performs all the step decision-making, then he is the decision-maker. When he makes the decision, is less clear. The selection of a feasible alternative may be the key item with the rest of the analysis and methodological process leading to the inevitable decision. We can see that the decision may be drastically affected or even predetermined by the way in which the decision-making process is carried out. Correct? At this point, we should ask, who was the decision maker? Who is the decision maker? It was one person, it were several persons. What are the criteria that was chosen to have the best alternative? It's important to highlight the elimination of feasible alternative may predetermine the outcome of the decision-making process. Correct? And it's important to mention and re-emphasize that only dominant alternative may be included based on either economic or non-economic criteria. So in this base alternative, you always have to keep the economic and the non-economic criteria. What is one specific example of non-economic criteria? The environment, correct? Or also social problems are not economic criteria. No, you can take the best alternative could be something that is going to bring you profit, is going to give you a benefit economic, but maybe not a social benefit, neither environmental benefit. So all these aspects need to be considered in the criteria. Now, let's move to the last step, which is audit the results. Audit the results is a step in which we compare the result of change to the predictions to ensure that the chosen alternative was implemented as planned and the results are as expected. An audit of the results is a comparison of what happened against the predictions. Do the results of a decision analysis reasonably agree with these projections? If a new machine tool was purchased to save labor or improve quality, did it? If so, the economic analysis seems to be accurate. If the savings are not being obtained, what was overlooked? The audit may help ensure the project operating advantages are ultimately obtained. On the other hand, the economic analysis projections may have been unduly optimistic. We want to know these too, so that mistakes that led to inaccurate projections are not repeated. So the audit is very important because not only help you to verify and validate, also to, as a lesson learned, to make sure that the mistakes that you have done in the past are not repeated. We want to know this, correct? Finally, an effective way to promote realistic economic analysis calculation is for all people involved to know that there will be an audit of the results, correct? Everyone who is involved in this process wants to make sure that there is going to be an audit of the results, that every time that you have taken a decision, you are having a book of lessons learned, making sure that when you take that decision, you were able to accomplish something, correct? So everyone wants to have an audit of the results. No, please do not confuse with financial auditing, which is other thing. This is audit the results, making sure, validating the results, making sure that the results, that the best alternative get the benefit that was expected, and if not, what happened? What are the lessons learned from that decision? Now, let's talk about one specific problem related with engineering decision making. I will tell you, and please write it down, and then you will follow the exercise with the slide, okay? A complete aggregate mix is required to contain at least 31% sand by volume for proper bashing. One source of material which has 25% sand and 75% coarse aggregate sells for $3 per cubic meter. Another source which has 40% sand and 60% coarse aggregate sells for 4.40 cubic meters. Determine the least cost per cubic meter of blended aggregates. How we are going to determine the less cost per cubic meter of blended aggregates? The less cost of blended aggregates will result from a maximum use of the lower cost material, okay? So the less cost of blended aggregates will result from the maximum use of the lower cost of the material. The higher cost material will be used to increase the proportion of sand up at the minimum level 31% specify, correct? You see here, 31% specify. So we're going to do a sans balance, correct? We're going to say that X times 0.25, which is here 0.25%, which is 0.25, plus 1 minus X for 0.40% is going to be equal to what? To 0.31, which is going to be, as I say it, is going to be the 31% that contain at least 31% of sand, correct? So we are going to have the formula in which X times 0.25 plus 1 minus X times 0.40 is going to be 0.31. X from this relationship is going to be equal to, S is going to be equal to 0.06. So we're going to have that X. Let me just here open a Word document so you can see. So what we're going to do is X times 0.25 plus, let me just put it more closer. So let's put it to 100%. Okay. So we have it X times 0 X times 0.25 is 0.25 plus sorry, but I don't have the, let me just do this. Just 1 second, please. Okay. So what I was saying is, if we go here, okay, so we're going to have 0.25, correct, times X, correct, and X, and we're going to have plus, so we're going to have plus here, plus plus 1 minus X. We have 1 minus X. This is plus, by the way. 1 minus X. 1 minus X minus X times 0.40. Only 1 minus X times 0.40. Remember something, that when we're talking about this, we're talking about the is going to be equal to 0.31 to 0.31. So this is the formula: 0.25 times X plus 1 minus X times 0.40 is going to be equal to 0.31. Then, when we do the calculations, we come out that X, that X is going to be equal to what? To 0.60. So this is going to be after use of 0.60. So what this means is that the blended aggregate will contain 60% of $3 per cubic meter material, and of course 40%, because it's 100 minus 60 is 40% of 4.4 4.4. Let me just print here of 4.4 dollars per cubic meter of material. Correct? From here, $3. We're going to have 60% that we just calculate, and then we're going to have the 40% of $4.4, 4.4 cubic meters, dollars per cubic meter. So the least cost per cubic meters will be what? Will be 0.6 times 3 plus 0.4 times 4.4. So it's going to be 0.3 plus 3. So it's going to be, sorry, let's use this one here. So to calculate this is going to be 0.6 times 3, correct? 0.6, sorry, it's going to be 0.6 times 3. Let me just repeat one more time here. Let me just write here so we can do a better. Okay, so it's going to be 0.6 times 3 plus 0.3 times 3 plus 0.4 times 4.4, which is going to be equal to 3.56. Sorry, 3.56. Let me just understand better so we know this is plus. Let's do this. We know that this is plus, this is plus, this is equal. So we go here, moving over here, plus 0.53 is going to be equal to 3.6 cubic dollars per cubic meter. So that is the least cost per cubic meter of a blended aggregate. So, as a homework, I have also sent you a PDF file. Please do the exercises that are in the PDF file. There are only 3 problems, and I hope that you can get to the solution. If you have any problem, when I come back, we're going to discuss, and we're going to go deeper if you have any problem. If you can do it, you will have your 100. Okay? So thank you very much for everything, and have a good day. Bye.